Welcome back to today's lesson, everybody. Today's lesson is called Neutralisation reactions, and we're going to build upon some of the reactions that we looked at last week. By the end of the lesson, hopefully we'll be able to use the pH scale to identify differences between acids and alkalis. And the main thing I'd like you to get out of the lesson is to predict the name of the salt again, but this time in a neutralisation reaction. As always, before we look forward though, we look backwards and we see what we actually learned last time. There are two questions on the screen. If you pause the video now and write the answers down on your paper, and we'll check them in a short while. Okay, so the first question then is about a metal and acid reaction, and it's asking you what the two products are, and that means what are the two things that are made. Well, if you have a metal and acid and you add them together, you will always make a salt and you will always make hydrogen gas. And then the second one, we've got our metal and we've got our acid, and I'm asking you to actually be a little bit more specific. I want you to name the salt as well. So zinc and hydrochloric acid would make zinc chloride, so the name of the metal and the chloride from the hydrochloric acid, and also chlorus plus hydrogen. And in the second one, we've got lead, sulfate and hydrogen. Lead being the metal and sulfuric acid turning into sulfate. Well done if you got those right, and if you haven't come across that before, maybe you need to look at the first video in this sequence. Okay, so the pH scale. The pH scale is putting things in order. It's putting things in order from number 1 to number 14. Now on the screen you've got 4 people. Okay, so you've not got 14, you've only got 4. And if I ask you to put them in order from the most famous to the least famous, what order would you put them in? Scribble something down now. Okay, so this is purely opinion. The order I'd write them down in, I'm thinking about the whole of the world. The person who I think is the most famous would be the Queen. I think most people around the world have heard of the Queen. The second one would be Muhammad Ali. Yeah, Muhammad Ali, an amazing sportsman and speaker for everybody. And he was absolutely known by virtually everybody in the world back in the 60s and the 70s and 80s. The person on the top left-hand corner is Zlatan. Now, Zlatan Ibrahimovic, yeah, he's a really well-known footballer, but not as well-known, in my opinion, as Muhammad Ali. But he is better known than the person on the right, who you probably know from Coronation Street. But do anybody in America know her? Absolutely not. So Kate Ford, yeah, you're pretty famous in Manchester, but probably not around the world. So I would go the Queen, Muhammad Ali, Zlatan, and Kate Ford, Tracy Barlow. So if I can put 4 things in order, then what I'm asking you to do is think about 14 numbers in order and think about some colours that go with that. So when we think of these 14 numbers, what we need to think about is where they come from and where the colours that are associated with those numbers come from. And the thing is this, that little picture that's on the screen at the moment is a dye. It's called universal indicator. It's just a dye, nothing special about it at all. But the thing about it is if it touches an acid or an alkali, it can change into 14 different colours. And the 14 different colours are the ones shown on the screen right now. So you can see that the reds are down in number 1 and 2, and then the blues and the purples go from 12, 13 and 14. And in the middle there at number 7, you've got a green colour. Okay, so what do those mean? Well, if I put universal indicator onto an acid, they will turn the colours from 6 down to 1. So number 1, if it went really bright red, that would be a really, really strong acidic compound, if you like. And number 6 may be a little bit weaker, maybe something a bit like lemonade or lemon juice. Now, if it went the blues and the purples from 8 up to 14, that would indicate to me that the substance we touched would be an alkaline substance. And again, 14 is a stronger alkali than number 8, which is a weaker alkali. So what about number 7? Green in colour. Well, number 7 would indicate a substance that is neutral. So the best substance to talk about there would be water. So if you had a universal indicator to water, it would stay green in colour, indicating that water isn't an acid and it isn't an alkali. Now just think about this for a second then. If you had in this hand pH 1 and in this hand you had something that was pH 14 and you added them together in the right amount, what pH do you think you'd make? Well, they'd cancel one another out, and the substance you'd make would be somewhere in the middle. You'd probably make neutral. and therefore that's where this term neutralisation reaction comes from. Now, in your normal lessons at school, you'll probably talk about different types of neutralisation reactions, and you'll talk about bees stinging you and what you would put on to neutralise that. You talk about maybe when you had heartburn and the kind of tablets that you would take to neutralise that too. Now, we're not going to concentrate on that today. We're going to concentrate on the real important thing, which is the reaction itself and the naming of the salt. So if I have an acid, which I put in red, and I have an alkali, which I put in blue, and I add them together in the right amount to neutralise one another, I will always make a salt and water, the water being the neutral part of it. Okay, so it's always water, not hydrogen like the reaction last week, but water. And it's the name of the salt that I want us to be able to do by the end of the lesson. So let's have a look at an example. If we had sulfuric acid and we had an alkali called lithium hydroxide, we know we're going to make water, but what would the name of the salt be? Well, it's dead simple. It's a little bit like last week. The first name of the salt comes from the metal in the alkali. So the metal in the alkali on this occasion will always be the first name. It would be lithium. And really, then, it's just the same rule as last week. Sulfuric acid would become sulfate. So I've got lithium and I've got sulfate. So the name of the salt would be lithium sulfate. And I would have water as well. Okay, so if you understood that example, then what I'd like you to do now is pause the video and I'd like you to have a go at this one. So we've got a different type of acid, a different type of alkali, but I'd like you to name the salt. Okay, how did you do? So sodium hydroxide and hydrochloric, so sodium is the name of the metal, hydrochloric becomes chloride, so the salt we would make would be sodium chloride, and we'd make our water as well, because it's a neutralisation reaction. Well done if you got that right. Okay, one more for us to have a go at together. So this time we've got nitric acid and copper hydroxide, and I'd like you to name the salt. Okay, hopefully you're getting pretty good at this now. So we take the name of the metal from the alkali, so that's copper, and nitric becomes nitrate, so our salt would be copper nitrate and water. And again, well done if you got that right. So here's the work for you to do at home. There's 6 equations for you to do, 6 neutralisation reactions that I'd like you to complete. So you can write them on paper and send a picture of it over Google Classroom to your teacher, or you could do it on a Google document. Okay, well done everybody. One more lesson to go before the end of the year. Take care.